Good afternoon all. As said, my name's Barney Nicholls. I'm with the AXA team. And today I'm going to talk to you about Pi. Okay, so it's a Raspberry Pi. So what's a Raspberry Pi? Well, it's a tiny computer. There's variations, but the smallest one being this. It's a Pi Zero. Tiny little thing. It's affordable. These start at under £5. And it's fun, honest. Okay, so where do they come from? Well, a gentleman called Eben Upton decided to create the Raspberry Pi. His goal was to create a low-cost device that would help people improve their programming skills and learn about hardware and how things interact. It was inspired by the BBC Micro and targeted at education. But it's quickly been adopted by tinkerers, makers, enthusiasts, people like myself, and I believe they've now sold over 11 million of these. Okay, so the variations we've got of a Raspberry Pi. The first one was the Model B. This is the one I'm actually using at the moment, one of the originals. I've had it in the drawer for years and eventually pulled it out recently and thought, I need to do something with this, and I've thoroughly enjoyed it. This has about 700 meg processor, about 500 meg of RAM. They cost about £30, but they're at version 3 now, and they've got up to over a gig, 500 meg of RAM, so they're quite powerful. The Model A, released in 2014, is a simplified version. You see, this is a network point. Where are we? There we go. And it's missing a network point, so it's a little bit cheaper. They've also created a compute module, which is used more in embedded equipment, things like 3D printers and other pieces of equipment. And the latest item to the collection is the Pi Zero, released in 2015. This is the original, which costs £4 something. This is the Zero W, which has Wi-Fi and Bluetooth built into it, and still costs less than £10. So, what could I make with a Pi? I could thought, this is my first project, a 256 node compute cluster, which is probably a little bit past my budget. Something very simple, a media streamer. These will very easily go on the back of a television. You can plug a USB device into them, stream films from other things on your network. Very clever. A phone. Yeah, I think I'm more happy with my iPhone. I don't think I'm going to improve on that, so I'll give that a miss. A drone. Now, a few of us like flying drones. The DJI is pretty good, so I wasn't going to bother with that one for the moment. Now, I live next to the sea, so the idea of a submarine appealed to me. This is a Kickstarter project, the Open Remotely Operated Vehicle, a version of which is powered by the Pi. It's very cool. So I thought, well, maybe I can go up. People have been attaching Raspberry Pis to weather balloons, sending them up into space. Now, there's a place, Portruth, the RAF place, they send up a weather balloon twice a day. So maybe you can send one up there. Maybe send the first passenger into space. But again, I decided no, not for my first project. So as my title may have given it away of this, sorry, the title that was in the doodle poll, this is the thing I chose to build, a weather station. Yeah, excitement. Okay. Now, I wanted the weather station to record things for me. So what do I want to record? So we want to record the temperature, the wind direction, the wind speed, the rainfall, air pressure, maybe light levels. And if I'm going to get clever with it, add a camera. Okay, so what components am I going to need for that? I'll need something to record the temperature, some bits to record the wind direction, the wind speed, seems to be jumping, rainfall, air pressure, light levels, and a camera. So I'm going to go into each of these components in a bit more detail. These things are sort of normally ordered from eBay. They're very cheap. And these are actually replacement components for a Maplin weather station. Okay, so the rainfall gauge. Exciting, isn't it? So the rain falls in here onto this area, and inside there's two buckets on a pivot. It's a tipping bucket. They empty. They're self-emptying. So all we need to do is count the number of tips. I know the size of the bucket. Size times count equals the amount of rain that's fallen in the time span I've been recording. Okay, the wind speed. Again, nice and simple. It rotates. A switch closes. I count the number of times it closes over a time span. A bit of math, and I know the wind speed. Now, that would be the average wind speed over that time period. But if I was to record the shortest time between activations and multiply that out over the time span I've been recording for, that, in theory, should give me the peak wind speed within that time span. That's not actually a gust. A gust is a little bit more complicated when it comes to weather stations. Apparently, it has to be over 19 knots and above 6 knots above the average wind speed over a period of 20 seconds. So I kept it nice and simple, relatively speaking. Okay, the wind direction. Now, this sensor is a little bit more complicated. Here it is. Inside that, there's a series of reed switches and resistors. So you put a current through, and as it, I'll try and use the pointer. As it points in a given direction, the switch closes and the resistance going through changes. If it gets between two of these, two switches close. So we have a different reading again. Now, so this gives us a chart, roughly, which we can use to calculate or that give us an idea of what the resistance is. And if we're passing a voltage through, what the voltage will be. Now, this is all analog. So we actually need to convert that into a digital signal. And this is an analog to digital converter. Actually quite simple, believe it or not. And once you've got that, you can then use a little bit of fuzzy logic saying, what's the nearest to this value? So you can find the nearest to it and then work out, oh, that's southeast. Okay, temperature. This is the external temperature sensor. It's a very simple device. It's using a one-wire interface. You can actually see 3 wires, 2 of which are power and 1's are data. And it will do from about minus 55 to plus 125. This costs 99p delivered from China. So the pressure. This is the pressure sensor I've used. It uses an I2C interface. That's integrated circuit. Okay, this allows you to use just 2 wires and attach multiple I2C devices to it, each of which can be individually addressed and spoken to by your application. This records the pressure in hectopascals, I think it is. And it's very accurate. It can be used as an altimeter if you wanted to. And the bonus is it also records the temperature. So I'm recording the temperature within my enclosure. Okay, the light levels. Again, an I2C interface. This records infrared as well as visible light. Now, I think that may be interesting, so I might be able to tell if it's cloudy or not. Because I think you'll find that clouds will block more infrared. We might be able to, with a bit of juggling, figure out from the data if it's cloudy or not. But yet to see on that. Okay, the camera. This is a standard Raspberry Pi camera. Okay, it's 8 megapixel. And it's got lots of pixels and video. Works a treat. I won't read it all out. Okay, so what's that lot going to cost you? Okay, here's the shopping list. I've actually used a non-standard version, which you can pick up off eBay for like £5 or £6. Total cost for all your components, you're looking at about £33. You might want to go for a Wi-Fi connected Pi, which add another £5. Okay. You'll also need, though, an enclosure to put it in. I bought mine from Aldi. I've got a lunchbox, clear plastic, so the camera can see out of it. I can get all the sensors in it. A power supply, it uses a 5-volt micro USB, so you may have one of those lying around already. You also, for this, you'll need some breadboarding, so prototype components. You may have them lying around already. There's a few other bits and pieces, things like blue tack, screw group, and some compression glands for the cables. Okay, so, now I'm a Windows user. Okay, Windows is great. I write in Visual, you can't see that. It's a C# in Visual Studio, best IDE. You laugh. All right, so you get a Raspberry Pi, you download an image onto an SD card, you plug it in, you fire it up. It's all very simple. What do you get? I don't recognize any of this. This is a Linux. So I'm going, I've got to learn about a penguin now. New programming language. And the command line. So, putting it together. So what coding environment did I use? I started off using one that's built in, comes on the image with the Pi, idle. This is basically Notepad for Python. It worked. I was able to get everything up and running. I switched to using PyCharm, which is a bit more like Visual Studio, and an easier environment to work in. Okay, so the first steps, what do I need this to do? I need to read the sensors. There are loads of libraries online, loads of snippets of code. Adafruit sensors, if you type in Adafruit and the component you've got, you'll find all the source you need to adapt to fit. I need to store the data. I store the data using a SQLite database, all free, all on the Pi. I was taking the pictures using the camera libraries, very simple, bang, onto the Pi. Excellent. Now, it's not really trouble, but I want to take pictures of the sunrise, the noon, high sun, and sunset. Now, as you're probably all aware, those aren't at the same time every day. So those times move. So I need to schedule the camera to take a picture at different times. So I use the library called PyEthem. Okay? Ethem is short for ephemeris. An ephemeris is a device or a library you use to calculate where things are at a given time. If you know your time and your location, you can tell when the sun's going to rise, where it's going to rise, when it's going to set, the position of the moon. There's loads of things you can do with it. Okay? Yay! It's all working. I'm reading my sensors. I'm taking my pictures. Okay, I'm recording everything onto disk. Here's the actual weather station itself. So this is my high-class Aldi lunchbox. That's the Pi there you can see here. And here's the breadboard with all the components on it. And some glands there with the cables coming out. That's the front of the Pi, and you can see there's the camera. I've used a clip-on lens from a smartphone to put around the camera to give it a more wide angle so you get a bigger shot. Okay, and here you can see here, there's the wind speed, rainfall, wind direction, and a box I put the power supply in. Okay, and this is my porch, and that's its view it has looking out to sea. Okay, eventually it's going to go on my roof, that's the plan, and it'll get a decent view. So, it all works. Data is being read. Images are being stored. But how how do I view all this stuff I've got on here? Now, if I could tweet it using Python, I would have Tweepy. Tweepy is another library. Excellent. Using Python, I was able to tweet data from my weather station directly onto the internet. As you can see there, there's a picture it took at high noon. You probably can't see here, but there's also gives the data about the temperature, the pressure, wind speed, direction, rainfall, and light level, all there. Okay, I won't go into some of the details of actually getting Twitter to not think you're a robot. But it was a bit of a pain, but it works. Okay, so I'm tweeting pictures. It's all great. Yay! Ugh. Right. It stopped talking to me. It wasn't tweeting. It wasn't doing anything. So what's the first thing you do if something doesn't work? You turn it off, you turn it back on again. I tried that. I turned it off, I turned it back on again. However, this doesn't work that well with an SD card running on a Pi. What happens is the SD card gets corrupted. Bang. I've now lost everything. It's all gone because it's all stored on there, apart from things that have been tweeted. So, what were the problems I've now got? It's too hot. A little sealed plastic clear case in the direct sunlight, funnily enough, gets quite hot, especially at the moment. I've been VNCing remoting into the Pi and making all the changes, tweaking things, changing the source code, running it again, all gone. All the recorded data in my SQLite database, gone. All the pictures that didn't get tweeted, gone. So, what am I going to do? How am I going to resolve this? Okay, so another thing I have no previous knowledge of, I use GitHub. I use ThingSpeak and a tinfoil hat. Okay, so GitHub allowed me to do all my source editing inside PyCharm, upload to GitHub, promote into the Pi, download, run it, all the sources nice and safe. ThingSpeak is an Internet of Things open source API. So any devices you've got can upload information to channels for free. So my Pi uploads every minute all of the information it's recording. As you can see here, so these update live. So it's got temperature, air pressure, wind speed. You might notice a slight bug with my wind speed. This is the average. That's 5,000 kilometers an hour. That's something I need to resolve. Okay, and the tinfoil hat. The Pi was internally getting to like more than 20 degrees over the external ambient temperature. With the tinfoil hat, all good. So what's next for my Pi weather station? It's just a weather station. But I've been playing with API.ai. I'm not going to go into this in a great detail. It's a bot framework. It allows you to create natural language queries and access devices. So I can ask questions like, how cold was it last night? What was the weather like this time last year? Show me a picture of this morning's sunrise. Okay, so this is I've played with this. This is actually a Skype implementation of it that I've got running, and you can talk to it. You can do a bit of natural conversation and also ask it details on the current weather. Okay, so that's it. Any questions? Hello.
Why are you pushing to the Pi and not having a webhook to pull from GitHub?
Because I don't know what I'm doing. Simple answer. Yeah. Yes, the only webhook I've used is with the bot framework. Okay, but I might come and talk to you about that later. I'm sure I can make it easier for myself.
You thought about moving to solar power?
Yes, I have. Whether I will or not, we get quite strong easterly gales in the winter, and a solar panel, I imagine, would have to be firmly fixed. I haven't. That will make quite a difference. That's why I'm tending to use this, because it should draw a lot less power. Anybody else?
What's your next upgrade?
Next upgrade? Well, I've got a wide-angle camera for it, so I don't have to have the little bit in there. And I want to get the bot working a bit more clearly. I have thought about air quality sensing and things like that. Let's see what we do. And then, like, yeah, make it solar powered. There's quite a few things just playing around with that I can do. Anybody else? No? Marvellous. Right. Thank you very much.